Hey everyone, welcome to Houdini Hangout. It is the beginning of April here, and we are back at it. I had a couple weeks of not being either able to stream or, having just way too much stuff happening to be able to actually to do anything reasonable. So yeah, I've been away for a little bit. So one of those things was GDC, which was GDC and very games oriented and things like that. It was fine. It was a good event. Got to see a lot of educators and things like that, which was great. And yeah, all the game stuff was cool, and we got to be a part of that. So that was great. And yeah, last week I ended up having a big presentation that was happening on the same night that the stream would normally be happening. So pushed things back a little bit because of that. So just had a lot of things to figure out there. And actually, some of the stuff that I did learn in that presentation could be a pretty cool thing maybe to talk a little bit about on one of these future streams. So yeah, that's something I've definitely thought about a little bit. Had a little bit to do with game engines, Unreal in particular, and just dealing with USD. I did a presentation a couple years, well, it's probably about a year and a half ago now, and it was all about USD into Unreal. And with the newest release of, hey Zach, how's it going, man? Welcome to the stream. And with the newest release of Unreal and with a few other releases since I did that talk, I felt like it was a good time to update some of our educators on that. So we did that presentation, but yeah, so that could certainly be something interesting maybe to talk about here a little bit. So anyways, that's what I've been up to the past couple weeks. I've been busy, even though I'm not on here doing my streams. So thank you for kind of hanging in there while I was a little bit AFK. Although I was not away from the keyboard, I was at the keyboard multiple times. But yeah, so really looking forward to kind of getting back into this and getting some, getting some new content, I guess, out there, however you want to look at that, get some new information out there, play around a little bit more, chat with you all, and kind of see what we can get up to. So tonight, I felt like it would be a really good conversation to talk a little bit more about some Heightfield advection. There is certainly, a lot of examples of how this may be done in different contexts. I know that recently, if I can talk, recently I think Panoply did a cool thing based around some Heightfield advection and things like that. I also did a stream probably about 6 months ago. I thought it was like way more recent than that, but I looked back on it and it was from September. So that is 6 months ago. And so I did a stream on that, and that was more about advecting masks. And not that it's that much different, but I think kind of talking a little bit about actually advecting the Heightfield information, the height information itself in a Heightfield, I think could be really interesting. So that's kind of the plan here. That we're going to be looking at tonight is maybe manipulating some of these other things that exist within Heightfield data. So that's sort of my plan. That's what I'd like to kind of get into here. And I think should be an interesting chat. And maybe there's better ways of doing some of this stuff. I'm always all ears to hear what maybe concepts or thoughts other people might have as to how they would go about doing these things. There's certainly many different ways of doing everything in Houdini. So I might be doing some stuff that might add some extra overhead, or maybe whatever, isn't the quote unquote fastest way of doing something, or whatever you might think. But I'm always interested in hearing from everybody. So I always like to kind of start off every stream by saying, if you do have something that you're thinking of, or that you want to kind of contribute back to these conversations, I'm always glad to have people a part of things in the chat. And, there definitely are no dumb questions here when it comes to Houdini. and always curious to hear sort of what it is that you're specifically running into or thinking, or whatever your comments, thoughts, questions, anything like that. Please don't feel afraid to put those in the chat, because obviously if you're finding that to be something, there's other people that are doing that as well, or running into those same issues. So you're kind of doing a public service by asking a question. And believe me, I know that I used to be the guy that would, well, I probably still am the person that would sit at the back of the class and just kind of quietly think, oh, I don't really understand that, never really speak up. But, I encourage you to try to break out of that mold that I find myself in as well. So anyways, that's just my usual disclaimer here. But yeah, feel free to jump in and kind of make your comments as you see fit. I think what we should do, so let's do this. Let's just kind of start diving into some stuff, and we can take a look at what we're going to kind of play around with tonight. So let's do it. So I have this. Let's see. Nope, that's not right. Side effects. Hey, and Keith. Yeah, well, it's been a while since I've done it. It's been like 2 weeks. So that would be why you haven't caught one in a while. Welcome to the stream. Glad to have seen you being in the Discord as well. Let's see here. So here is what I was kind of playing around with. I had a question that came from from somebody on the, okay, thank you. Go away. And this was sort of what I had set up. I posted this on social just to kind of say, like, this is what we're going to kind of be playing around with. And truly, I'm actually not super thrilled with how this turned out. I think there's some stuff that could certainly be, that could be adjusted on it. That could be done a little bit better. But, the idea here is that we're taking this height field information and we're going to be pushing it around using a velocity field, right? That's kind of the idea of advection and how that works. So what I'm basically doing here is I'm introducing this this height field data. So I'm kind of layering height field data within a SOP solver and using that to kind of process this and make it have kind of the feeling of it being a simulation of some sort. So let's kind of start and take a look a little bit at what's going on here, and then we'll kind of slowly build this process up. I've really only done this the one time, so if I run into any problems, I've got my handy baked version, pull it out of the oven and it's all ready to go. But hopefully it won't come to that. Hopefully we'll be able to get something interesting going here. But yeah, so the first thing that I think you kind of need to, in this process, kind of think about is what is it that you're sort of starting with, right? So let's drop down a geometry node here. We'll just say height. Oh, geez, that caps locker's on. Height field advect. Maybe I'll just call this sim height field advect. And sims are purple in my world for whatever reason. So let's start with just a height field here. And by default, height fields are terrains, and so they're generally quite large. In this case, I think this is a kilometer, 1,000 meters. So you can have it at that scale. It's really, I don't think you're going to run into too much that's going to be an issue there if you keep it at that scale. It's kind of up to you, I guess. One thing to keep in mind with height fields is that if you are using, noises or, the general tool set, that you will run into scale, some scale differences with the parameters that are set when you drop down a thing like a noise, right? So like if you drop down a HF noise and use this here, it's kind of by default set up to be, looking like a terrain at this scale. Obviously, if we were to bring this down to 100, you're going to get a much different type of scale, or a different type of, sort of starting point here. And it's not going to kind of create that big terrain that you're sort of looking for. Another thing to keep in mind here is that the amplitude is somewhat high here, because when you're looking at this over a kilometer, that is going to really show itself. Whereas like in this little area here, hey, welcome to the stream, Third Dimension. Welcome. So in this case, you might want to keep the amplitude in mind, the element size. So you might want to bring this way down, but as you bring this down, obviously we have too much amplitude now. And so we might need to adjust it a little bit here based on those things. So just some things to keep in mind as we're kind of playing around with this. The real sort of important thing here to keep in mind as well is the resolution of this grid. Right here, we can see we have, if you look down here, we have 500,000 voxels. Middle click, we can see here, that's because we have two height fields that are on top of each other. We have the height and the mask. And just to kind of make sure we're all thinking about this on the same level, these are two-dimensional volumes, right, that we're dealing with. They have two axes that we're kind of working with here. When we look at this, we can see that they're 500 by 500 by 1. And so they are not, they don't have they only have one layer of voxels, right? It's only one layer thick, and it's 500 by 500. So that is kind of the defining feature of this. And here we have the grid spacing of 2. So basically every 2 units, we're going to get a new, that's going to be the scale of our grid is 2 units. So in that case, that's why we're seeing having 500 by 500 showing a kilometer on each side. Math makes sense. Multiply by 2, you get that result. So I guess we can just kind of stay at this scale. Obviously, we don't have anything else in our scene that's really going to be affecting this. So your mileage may vary, and you may want to start with a smaller scale. Just keep in mind that some of these noises and things like that are going to just change slightly if you have it at a different scale. So just something to keep in mind. Actually, no, scratch that. I'm going to make this at a smaller size because I think that will actually make our velocities easier to deal with because they don't have to get so crazy high. So again, let's set this to 100. Sorry. Just kind of thinking on the fly here, and that I think will actually make more sense for us. So we've got that. We could use the noise in order to do something interesting here. Let's also change the scale of this, because right now we have only 50 on each side. So if we change the grid spacing to 1, that's going to make 100 on each side. And so let's do it 0.2. Oh, cool, Chris. Well, hopefully we can make some sense out of all of this for you. So now we should be at it while we're at a smaller scale here in our scene. We only have this at 50, plus and minus in both the X and Z axes. Now we have a grid spacing of 0.02 because we reduced the size by 10 and the grid spacing by 10 as well. So that is, now we're back at the same scale, the same number of voxels. We're all kind of back to square one there. And we should be able to take this element size down by 10, I'm thinking, and then maybe the amplitude down by 10. Let's see. Yep. Yeah, there we go. So now we're basically at the same sort of look that we had in the other example. But I think something that would be maybe more interesting to do here would be to not start with like a terrain per se. Well, it could be interesting, I guess. Anyways, let's actually start with the terrain, because that actually might be kind of cool looking. We'll see what it looks like. But so we've got this noisy height field. So what I was showing in my example was actually just some deformed height field information. So pretty much it was something like this. And then I think if I do HF pattern, I want to say, yep. So I did like a height field pattern like this. And then, hi, yeah, welcome. I am XNNYXD. Welcome to the stream. Oh, yeah, I'm doing great. Thanks for watching, and I'm glad you enjoying the videos. So what we could do here is any number of things. We could do, cells and patterns and things like that. I got to change the height here. So you could do something like this and start with a cell pattern. You could do any number of different height field related things. I was kind of playing around with this at first as well. You can do some interesting stuff here. You can kind of play around with that and get some neat things, or maybe stars and scale those down. That's kind of interesting as well. I actually think that was what I was doing in mine. I think I was doing that, and then maybe just like adjusting a few things here and there, and then rotating this, I think. So that was sort of how I was doing that part there, where I was kind of having those things jump up. And I think I was just doing an HF transform, and just rotating it, I want to say. I think that's all I was doing. That one was, let me just double check that. Yep. We're just rotating it. So yeah, you can do some of these really simple things, translating and rotating and offsetting and height and stuff like that. But I think let's just kind of talk about this too really quickly, because I think this brings up some interesting information to kind of process here. Because if let's set these back, right? So we've got this height here, and if we look at this, let's see here. I'm just going to pull up this information thing, pin it down. I think maybe we could refresh this automatically, and that should get us what we want. Really just care about this information here. So, yeah, here you can see that we're changing the height information here for our transform, and that's adjusting the size and the min-max and everything like that. And if we look in here, though, we're seeing a little bit of a different story. So there's kind of two different things happening here, right? So here we're seeing that things are changing in our viewport and in this little pop-up. But in our geometry spreadsheet, the point positions of these two volumes aren't changing when we're doing that. So there's something happening there that we have to kind of think about in a little bit of a different manner. And if we translate these, it does change, right? So look at I think this highlighting maybe will give us a little kind of tip as to what's happening here, right? So when we grab this translate and move it left and right, or, backwards and forwards, whatever direction you're kind of looking at this in, we're actually changing the point position of those volumes in space. And you can see that red box is moving, right? But when we're changing the height offset, that box doesn't change at all, right? Now, the visualization of that in here, we're seeing this kind of SDF type visualization here. And it's kind of that same as the SDF visualization. It's not an SDF, but anyways. So what's going on here? Why are we moving the height offset, but it's not changing the actual position of that grid? And again, the reason for this is that we're dealing with the two-dimensional volume, and this visualization that we're seeing here and this geometry that's kind of being created is actually just a representation of the height offset that is being stored in this volume, right? In this height field volume. At least that's kind of the way I like to think of it, because we are manipulating these values, right? And it is moving up and down or whatever, based on its height, the height value that we're storing in this, right? So that's kind of the way I like to think of this. It's not really that we're creating a shape per se. We're storing a grid of height values in this big volume, right? So it's really just a container for storing these values, and that's what we're going to be manipulating here. So in the last time that we kind of looked at this, we were kind of manipulating the mask side of it and revealing things as this mask kind of advected. But you can also do the same thing with the height information, because when we're advecting the mask information, we're just advecting something that's like we're just advecting numbers basically through this volume. And so that allows us to be able to do some some of the very same things to our height field data and have it move around in that same sort of way. So we're going to be we got to kind of keep in mind that while this stuff is kind of going up and down, it's really that there's this grid of values, almost like a pixel, it's like a picture that's storing height values in it, right? And that's what we're manipulating. So that's, I think, an important thing, or at least a way to think about this that's a little different maybe than, if you had an SDF that's in its own position in space, and you're manipulating that. I think that's a little bit of a different beast, because you are actually dealing with a 3D grid of voxels when you're dealing with an SDF. This is, again, just a 2D grid. And something that I think might show that, actually. Let me just think here. If we can get this out. Can we? Volume VOP. Let's see. I find the volume VOP to be a lot easier to deal with than, so you can, since this is a volume, you can run these processes on them. And just think here. What could we do? I just am thinking how we could visualize this. So I think what we could do is, can we do an add point? Will this work? I don't know if this will work or not, but we'll see. Point position there. Does that actually do anything for us, or no? No, unfortunately, it's just going to add it at the center. Okay. So, because this is kind of going over all of the voxels in here. Yeah. Okay. I was just thinking maybe we could visualize that a little bit better, but that's okay. We'll just kind of think of it that way and continue on here. So, yeah, it is sort of like a displacement map in a way. I think that's a very fair assessment, Ankit. I think that's a great way of looking at it, right? It is a map, and really, when you look at what we're doing with, just as an example, let's just pull up a sphere here, right? And let's do UV project, and this will make sense in a moment. So if we take a sphere, UV project it, let's do this polar. And if we were to do a, what is it? Texture mask paint. That's what it is. So if we do a texture mask paint using geometry, right, we need to make sure that it has a UV setup. This is our newer painting, newer way of painting things, attributes on geometry. In this case, float values, right? It's a mask. So it's a mask to be able to paint in here. And so when we paint this, we're now painting, values into a volume. And I think we should be able to do this if I'm remembering correctly. So on the output here, we have our mask volumes. And if we take a look at that, we'll see now that this is actually a 2D volume. Now it's positioned differently, right? And I think that was intentional by the developers, so that we were looking at this in its correct kind of 0 to 1 space, right? We're here we're in, we're sort of in 0 to 1, and this is in UV space. So if we were to look at where we painted here versus the geometry, this would match up in UV space. So this is sort of the same concept, right? So you're painting that section right there, and that's a UV kind of representation, but it's 2D, right? It's a 2D, volume that we're looking at here. If we middle click, we can see we have one volume here. It's 1024 by 1024, and it's, it's kind of all synced in a way. It's similar. It's just visualizing that information differently, right? If we were doing this on a height field, it would show up as that kind of red mask. Or if we were doing this with like height data, it would show up as that displacement height, right? So that's sort of a way of thinking about this a little bit. So just something to kind of keep in your mind. All right, this is a bit bigger. There we go. So we've got this sort of interesting shape here. I'm just going to minimize that. So let's maybe start with this, and I think that could be sort of an interesting thing to do here. But what we need to do is have a couple of different ways. We need a way to kind of push this around. We need some sort of a velocity field that we can have set up. So I think probably our best way of doing that would be to now, what I had done originally in that example that I posted was I actually used the what do you want to call it? I made kind of a terrain in the background and used the slope of that, the gradient of it, basically, to drive the display, where this thing is moving. But I think we could do something a little bit more interesting here, where we could kind of create our own custom, sort of velocity field. And what I'm going to do is, let's do this. So we can kind of just manipulate these different height and mask values here. Maybe I'll just bring this up a little bit so we can just kind of keep track of what volumes we have here. So they're probably right behind my head, isn't it? Yeah. It's literally right behind my head. Maybe I'll do this. Maybe that'll actually be better. You can kind of see it up there. That actually might be better. I never thought of that. Anyways, we'll keep it up here just so we can kind of keep track of way up there what type of volumes we have here, what type of height fields we have. So let's do a HF copy layer. Yeah, that should work. So we're going to do that, and we can just take our mask source, and I'm not going to copy any data here, and maybe we'll just call this vel, and that's just going to make another volume here that's going to be that we could store that data into, right? It's just a way of basically copying that information and just making sure that we sort of have that available. So we're not going to actually act on that, so this will be kind of a separate stream, and we'll play around with these and see how and where we want to get with these. But so what we could do then, the only thing there, sorry, just thinking, that is a float. Sorry, just thinking of how I did this before. Right. Okay. So that's what I could do. I could do, I can just do a couple of vel.x, and we'll just copy that, make 3 of them, right? Because with, this is how you would do it with sort of, height fields or I'm sorry, with regular volumes in Houdini. So that should work. That should work just fine. And what we could do there is we could manipulate that in a few different ways. Yeah, because this really isn't going to be this really isn't going to be this isn't going to be something that actually gets used by the height field to visualize anything. It's nothing that it really knows about. We're just making a volume that's in the same position as it so that we don't have to worry about having them match up or anything like that. Am I going to show some Pegasus nodes? No, I don't think so. No, that was not in the plan here. Just doing some height field advection. So no, we're not going to do any of the stuff from Pegasus. I haven't really followed that super closely just because I'm not that close in keeping track of all the game dev stuff. But I've seen some of the work, just kind of from afar, and it seems pretty cool. But I don't know exactly what the tools they've actually made are. Okay, so now we've got these velocity XYZ, and so that should work just fine for us. And what we could do there is do let's see here. So we do a volume vop. So this time we should be able to do this. So we don't actually need this because we're not dealing with density. Oh, you know what? That's right. There is actually a HF VOP. That's right. There's a height field VOP. I forgot about that. So this, what this is, it's really very similar. It just has this height already bound here. So it's kind of nice. It just does the bind for you already. What we could actually, we could do as well, we could do a bind, just a regular bind here, and we could pull in, the velocity, but actually we just need to bind export that. We don't need to worry about the input because we're just going to overwrite that with some noise, I think. So let's do this. Let's do val, oops, hit caps there by accident. So let's do val, and this is going to be a vector. It should be able to pick that up, no problem. That's my hope at least. And let's look at Let's do maybe we'll just do like a curl noise with the position of each voxel like so. Then the noise output should go like that, and that should hopefully be writing to that velocity, those vectors there. So that should be good. And just thinking here, let's just make sure that is actually we're going to say make val vector. I'll say volumes. All right, so what we can do is we can just take a grid with some scattered points, and we can use our what is it? I always forget the name of that one. Volume trail. So points to trail, velocity volumes, and there we go. And let's make this a little bit bigger. This needs to be at 100 by 100. And I think we just want to trail these a little bit further. Interesting. Velocity volumes, vel.star. There we go. Okay, I was going to say, that should be working. Why is that not working? That's really strange. Let's do this. Back by time. Oh, right. So what it is we're actually dealing with here is we're getting upward components, and I think that's actually stopping it in its tracks. So let's just do this. There's a component where we can set the vector 3 component. So we have this velocity, right? And we don't want it to go up or down, right? So we just want y to always be 0 because we're keeping this in a kind of a horizontal type thing. So let's just pull out our component 2 and set that to 0. Now, all right, now we're getting somewhere. So we've got our curl noise here, and let's adjust this a little bit. So maybe we'll do frequency. Oops. Yeah, there we go. So something like that. We'll maybe add a little more frequency in there. Add some more amplitude. Just kind of play around with this a little bit. Get some interesting looking stuff. So there we go. We're getting some interesting kind of curled velocities, right? We see that this is actually happening here. And so one thing to keep in mind here is we do need to kind of set these velocities, at a decently high level. We'll set it at 100, I guess, for right now. We're in a pretty big space here, right? As far as, the actual scale of what it is we're dealing with. So we need to kind of manipulate that a little bit. And then obviously we can offset our noise here as well and get some animation that way. We could, you could use any number of noises to do this. I'm just kind of randomly picking something. And maybe we'll just offset this by time. So we'll do this time offset. And I'll just multiply by constant. Don't want it to go too fast, so maybe we'll just give it like a quarter of its speed and just kind of see what that looks like here. That might even be too fast. Let's scale that down a little more, like maybe like that. Yeah. Cool. All right. So we've got our curl noise with some, making some velocities here. Vel.x, we're looking at the vel.star here, and that's obviously creating that for us. And, you can change this around and do whatever with it. Cool. All right. So that's all working. We've got noise. Well, like that. All right, cool. So that's good. Now we need a way to advect this. And what I've found to be a pretty straightforward way of doing this, and I think this is what we talked about in the last time I did this, was converting these over into a VDB, using the VDB advect, because I feel like that makes a lot of sense. Actually, it kind of really, like I said, it's a pretty straightforward way of doing this. You're just kind of letting the node do what it needs to and just giving it a couple parameters. So let's do that. Let's actually use that to do our advection. And if people have other suggestions, I'm always interested to hear those as well. So what we're going to do here is use a VDB advect. We can use that. Then that's going to look for VDBs to advect and the velocity. So that's good. But we also need these to be VDBs, right? Because these right now are volumes. So let's do a convert VDB down here. Grab that. And so now we've got these as a VD, or no, sorry, this is as a volume. We're going to turn this into a VDB and it's going to disappear. And you'll be like, oh crap, everything's broken. Now that's not true. It is still working the way we want it to. It's just that now that it's a VDB, Houdini doesn't really know how to visualize this, right? It's still volume. It still has all the same data in it. It's still the same number of whatever. It's all the same things that we sort of would expect. However, we've now kind of, we only have this known at, we can only show that visualization when it is an actual volume and not when it's a VDB. So that's one thing to keep in mind there. So the VDBs to advect is going to go in this first input. We're going to specify, we can just specify under the group just that we're going to do the height one. And then we're going to do the same thing over here with this. And I think what we could do here, let's just see. Maybe we'll just do a blast just to kind of cut down on some of the data that we're dealing with here. We'll do a blast and we will take mask and height and we're just going to delete the non-selected. So now we should just have, oops, did I do that right? Oh, sorry. No, just delete the ones that are selected. My bad. So now we should have the velocities and this should convert it into a VDB. And now we should have a vel XYZ and is this looking for... Yes, so let's do a vector from scalar, VDB vector from scalar. That should be what we want. There we go. And that should give us our velocity as a vector VDB, vect3. These are all float, right? So that's the difference between that there. And yeah, that should be good. Let's just change this to make sure it knows it's a displacement velocity acceleration. It might not be super important, but good to do. And then if we bring this over here, volume grid does not have uniform voxels. What does that mean? Okay, interesting. Okay. Slight adjustment here because I am doing this a little differently than I did before, so that's interesting. I did convert these all to VDBs. VDB1 there. Oh, velocity, maybe that is what's missing here? No. Okay. All right. That's fine. Let's do this a little differently here. Let's do okay, so what we can do is instead of doing it that way, let's convert this here and we're just going to kind of play around with this a little bit. So we're just going to change the order we're doing things a little bit here. So let's blast away those that just the one that we won't need, which is going to be mask. So we're only going to have height at this point. Let's convert that to a VDB. So now we've got a VDB of height. And what I'm going to do is I'm just going to do a VDB analysis on this. This is actually what I did before and it worked fine. So let's do this. We're going to get a gradient. That's going to give us a vector output here. We're going to give it a custom name, call this vel. And that's just going to kind of set us up hopefully with the exact same yeah, I see what happened here. So somewhere along the lines, it's probably here. We actually ran into a different number of voxels. That's really interesting. So if you look, probably might be a little hard to see here. This has 250,000 voxels in it, which makes sense. That's the math that would make sense. This one here has 245,000 voxels, although it's 500 by 500. That's really odd. I don't actually know why that's the case. That's very strange to me. I'm sure it's something dumb that I'm doing. It's all fine here until I convert it. Well, let me just see, actually. Let me do one other thing here. Let's convert this first. Do we run into any voxel number issues? Yes, we do. Here, because there's nothing in it and it's... no, what it's doing is it's actually adjusting the pruning. It's kind of like pruning, I think, some volumes that don't have values, right? Because VDB likes to, I think, what is it? Is it sparse? Is that the term I'm thinking for? Yeah, it's sparse kind of grid. And so what it's doing is deactivating some voxels that it feels like it isn't necessary to do. Let's just see here. Activated tier. No, I'm just trying to think if there's something here that I should be doing. Should I be doing that? No. Okay. Anyways, I'll just put this back here where it was, because that was technically working. It's just doing some weird stuff. So let's do this, and this will give us that 500 by 500. And now we're all kind of squared away. So I think if we just bring this over like this and have it work on vel, should be fine. Let's just make sure that that's still sort of doing what it is that we wanting it to. Let's see here. What's wrong? There we go. So now, yeah, we're in the same boat. So I just am doing this in a slightly different order. That was just a mistake on my part. This should work fine now. So the problem was that I think because we were converting after we did this, this step and put some values into those velocity grids, those volumes, it's trying to find places where it can, you could use a VDB activate as well, but I think we're basically using the same thing. And really all I'm doing here is just using this node to just basically make a scalar into a vector. It doesn't even matter what calculation's going on here. You could do any calculation. It's just making that velocity grid for us. So yeah, but VDB activate could work as well. It's just the problem with VDB activate is that it feels like that sort of wants to have a 3D position, and I want to make sure we keep it just in this 2D kind of plane. So this is just sort of a weird way of getting around that, I guess. And it doesn't, I feel like there should be a better way of doing that. Maybe there is that I'm not thinking of. Yeah, it's like the volumes just need to be activated. The voxels need to be activated first. So yeah, that's sort of what a VDB activation would do, the same thing. So anyways, this is doing the same stuff, all good. And we should be able to put this in here now and it should be happy. No. What? That's really weird. I must have missed something here. Right. What is going on here? Okay. Give me a second. Get rid of mask. Volume grid does not have uniform voxels. Okay, that's really interesting. All right, so let me just take a look at this. This is my example that I had from before, that I had this is where the video came from. All right, so a little different here. I was using this Heightfield noise to drive my my gradient here. to drive my velocity. So this I am actually using that to yeah, Lepempator, I did uninstall knobs. It does not not uninstall. I feel kind of bad because that was just a throwaway joke that I made when Tom asked for some stuff, and hopefully, yeah, Knops is great. It was really fun. It's a lot of fun to play with, honestly. That was really good. But yes, I did uninstall it, no problem. And I think it just starts actually with a bat file, so you like auto start it or whatever. But okay, so what we're doing here, just to kind of look at this, is I have the height coming in, converting it to a VDB. Let me just make sure I'm not doing anything weird here. Okay, that's all looking good. So let me just set those the same just to make sure. Okay, same here. Let me just do this again. Because I wonder if something just got weird in there. No. What? That is so weird. I had mine at 10 and did height and velocity there. Okay, let's look back here again. Double check what I did. Make sure nothing's stupid. VDB. Is that what I did? No, height is there. Let's convert height here as well. Make sure we're doing this all by the books. Group height. Custom name vel. No, I think that's how I did it over there as well. Let's just check this. All right, I'm surprised that this is not working. Val vector, yeah. I even did the same thing here. Set vector component. That's so weird. So it's not that. Oh, was vector size 2 instead of 3 in VOPs? Interesting. Let me take a look. Could be it. Oops. Let's take a look here. Oh, gotta change my thing here. Got vector 3 there. No, it's vector. Unless that's what I... should be vector like that. Just out of curiosity? No? Okay. Yeah, that's normally what I use. I mean, that's what I did as well. No, it's component 2. The second component is what I'm setting. Yeah, I see what you're saying. The vector size is 3. It's a 3D vector. But the component 2 is the one that we're changing. And I again did that. No, it's fine. No, that's great, Robin. I appreciate the suggestion there. That's great. I don't actually know why this isn't working. Okay, let's just go back to what I had done before, because that did work just fine. So I'm gonna make another branch of this and just keep doing it. Okay. No, it's no problem. No problem at all. Thank you for your suggestions. I appreciate it. All right, so let's do this. Let's take a different Heightfield noise here. Let's do HF noise, because this is how I did this originally. So I did this and got a really sort of rough terrain. We'll do something maybe like that there and turn the scale of it down. We're going to adjust the roughness of this so it's kind of nice and smooth. Like that, and we'll let that sort of drive the movement of this. So that's what we're going to get there. Let's do, sorry, let me just check that again. This is all in the solver here at this point anyways, but yeah, we convert it, analyze it. Cool. So let's do a VDB convert. Sorry, convert VDB. I always say that the wrong way. Yeah, of course. I'm glad to show a little bit of it. It's definitely a weird topic. I mean, for sure, it's very strange. But yes. And it's weird. It's like working in this other thing, and I am not seeing that work here as well. So I'm kind of curious why that didn't work the same. Anybody going to off Barcelona? Oh, off is tomorrow. Cool. No, not me. I will be at FMX, but not at off. Should be cool though. I'm sure all those things will be posted and things and stuff like that. So that is definitely would be a really cool one to go to. It seems like that'd be a neat event as well. Height, custom name, val. Okay, yep. So that's working. And just to check it, I'm just gonna grab this volume trail, and we're going to do this, and that should, yep, looks like it's kind of following along with this terrain that we had before here, right? There's, again, we're calculating, the gradient is just basically calculating the direction of the change in value, right? So it's going to be going from high to low, I think, if I'm thinking that correctly, or low to high. Maybe it's low to high. Yeah, it's probably low to high because I think it's, anyways, it's one of the directions, whatever. So anyways, that's, now we have this velocity thing here. What I did over here was just basically did some simple things like adding some turbulence into that. But it shouldn't matter for our situation here. This is just negating it, multiplying it by a constant, things like that. And we're binding this velocity in and out in order to add some noise into it and things like that. We could just, let's see here. So we've got this as a VDB. I could also, sorry, now I'm going back and forth like crazy. Yeah, I'm going to blast those as well just to make sure that we're not dealing with other stuff here. So let's do a blast. So we don't have the mask in there. So we're going to blast out mask. Now we should just have velocity. It's a vector 3. Cool. All right. So, let's do an attribute adjust. No. No, we can't do it that way. That's right. I was thinking there was a volume adjust for vectors, but there isn't. And that's why I had that thing in there. So I'm just going to copy this over just to bring this over for my other thing. Basically what this is doing is adding some turbulent noise into it. And so if we look at this now, oops, bring it like this, we should see that there is some noise being applied here. So if I go in here, play around with this turbulent noise, here's the amplitude, and this is kind of doing some weird kind of adding some noise into it. I'm just going to do it like that. That's fine. Doesn't need to be anything more than that. I'm also multiplying this by a constant to make the just playing around with the scale of it and stuff like that. So just to make it go faster or slower. But that should be fine. And if I drop this in here, what do we got? Volume grid does not have uniform voxels. What in the heck is going on here? There's something really funky going on here. I don't like it. Why is it doing that? Yeah, just suggest doing a VDV. Robin's just saying there's a vector merge if you have 3 separate ones for val X, Y, and Z. Yeah, that is sort of, yeah, I was actually doing that over here. Works every time. I know. That would be nice if it was that. But what it is, I do not know. This is really strange. I mean, I did, there we go, reset the viewport. Let's just try something here. 1. Interesting. Okay. Let's see. So this would be half of the size now. So I wonder. Oh, that's so bizarre. I wonder if it didn't like that it was a decimal point for the voxel size. Because that's, I think, is the only difference between these two. Because I was actually doing this at a large scale as well. Yeah, that's probably what it was. That's probably what it was. Just was not liking that. Okay, well, I think we solved it. So all this to say, we could probably go back to any number of these, any number of these different ways of doing this. Let's see. I think I like this method the best. Getting rid of. Okay, so let's clean this up a little here. Guess we figured out the problem. That's good at least. Oh, that's fun. It's like spilling off the edges because our grid needs to be bigger. This needs to be, it's 250, so we'll do 25, 125. Yeah, it's definitely very strange. Very strange. Wait, what am I? Oh, 250. Duh. 250 is the size we need. There we go. And that should be right. And now we're good. Yep. Okay, great. Yeah, it's really strange. I don't know why that is the case, but it seems to be the case that happened. All right, so let's do that, and that'll be our noise. Let's kind of play around with the scale a little bit here just to make sure that we're in a good spot. Maybe give it just a little more amplitude. Maybe change the frequency a little bit. Something like that, and this should move through like that. Yep. Cool. All right, so we've got some curl noise going. Nice. And then we've got this VDB advect step here. And then if we do another convert VDB after the end, then bring it back. There we go. Now we have it going through this advection step. Now, the interesting thing here is that we're not really seeing much happen here because the advection really just only happens at this one step, right? So you need this to actually be happening, across, kind of building up over time. We should be able to push this, and we'll see that this kind of all folds around and does its thing, right? So we're starting to kind of push this thing around, and we're giving it a time step to move this around. So you can see that this is starting to do something kind of wacky, right? Kind of interesting. So this time step is a big part of this, right? So how this is going to get calculated. And the sub steps also can kind of allow for this to be, to have more kind of smoothness and things like that to it. So maybe we'll do this at, I don't know, maybe we'll do it at like 5 or something like that. So, so really what we need to do is, well, let's go to this. Actually, that was the one we wanted to look at, right? So in fact, let me just delete this one more time because now we should see it actually kind of doing more of what it was that we were expecting, I think. Hello? Right, there we go. So you can see it advecting now through this. And again, this is sort of the same idea where we need to maybe multiply this by a little bit more, maybe like multiply by a constant here. again and just maybe give it another little boost. Maybe we'll do it by like 10. That's probably too much. Maybe like 2 or 3 or something like that. Yeah, just give it a little more oomph. Cool. All right, so let's do this. That all looks good. And so what we can do now is a couple of things. We really want this advection step to happen within a solver, right? So I'm going to leave this. Let's get rid of that, and let's get rid of this stuff as well, because I actually like this method. I think this works good. We're getting rid of our height of everything but our height field. We're converting it. We're doing this analysis just to kind of pull this velocity out of it, and then we're adding some noise to it. So anyways, I think that works great. This is just a visualizer. I'll just put a null down here just to kind of see what this looks like. I think that's right. God, I'm terrible at spelling. Sorry if I'm spelling that wrong. Okay. Go off. Okay, cool. So what we need to do is put this inside of our solver. So I'm just going to pull this over here just so I can kind of remember exactly how I had this set up. Cool. So we have that solver, and let's do this. So we're going to just drop down a solver here, and the first is obviously going to be this height field that we're dealing with. So we've got that. So we don't need any of this. So let's pull this into the first channel here. And then, excuse me, we're going to grab this velocity here. And this is what we're going to output. This is what we're going to put inside. So we're going to copy that, paste it in here. We're going to start with this VDBs to advect like that. And then this one here doesn't need to go to input 1. It needs to go to input 2. So that will now give us the same output that we had before. And this will be the bulk of what it is that we're doing in our solver. So let's reset this simulation. Oh, actually, you know what? Now that I'm thinking of it, we don't even need this convert VDB in here. We can just do that inside of here, just this VDB advect. And then down here, do we need that? No, because as long as we keep it as a VDB, that's fine. We don't need to swap it back to a volume. Actually, I think I was doing that in mine, and that is stupid. Why was I doing that? That seems like a dumb thing to do. Well, let's see how the performance is on this, because we want it to come. You want to make sure that whatever's coming out here, right, is a VDB, and whatever's coming in here is a VDB, because we're going to use this VDB advect. So really where we want to change this is after we get outside of this. So we want to do all of this solving on the VDBs and then go from there. So let's see. And yeah, this is like infinitely faster than what I was originally doing, which is interesting. So you can see we're getting some interesting results here. There's some interesting stuff happening. Now, we're kind of like, I think blending, like we're kind of advecting and blending all these values kind of down to nothing at this point. So that's sort of what's happening here. So let's see here. Let me play this back at real time. And I think just based on different elements of this simulation kind of, being pushed in different directions, I think we're kind of like starting to average it because the noise is moving in it. I think we're kind of averaging it out so it kind of goes away, and some of these values might just get pushed off the edge and kind of get moved around. So, so let's see here. So that's what we're doing here. Just want to see how this looks. Yeah. And so maybe a better thing to do than this curl noise. I mean, you could obviously do a bunch of different noises here. Maybe a better thing to do would be something like a turbulent noise. I think this is what I was using in my other one here, if I'm remembering correctly. Yep. And for this, we could just do sort of the same thing where we're getting the offset like that. This is going to be a 3D noise like this. And let's bring the frequency down. Down, up. What am I thinking here? Oh, right, I have alligator noise. That's why. Don't want that. Yeah, since we're at like, I think because we're at huge scales here, we're getting some weird sort of stuff going on. But let's kind of play with this and see what we can. I think it actually works a lot better with like wider noises and things like that. Just going to play around with some other noises here just to see if there's anything I like better. Wow. What's happening here? Position. Sorry. I guess it's just not working as good. All right, we'll just stick with simplex. That should be fine. Cool. And then if we look at that, that should look a little different as well. So let's go back here like this. See that those are kind of all pushing together and doing their thing like that. And maybe a more interesting thing to do would be to add a little more amplitude in here like that. Then we could do that, something like that, right? And maybe even, oh, right, the time step is quite a bit big there. So let's do that. There we go. That was actually probably why this was happening the way it was. The time step was actually probably quite a bit too large, and that was causing, you know, some real. It was causing it to push it too far in one step, and I think we were losing some precision from that. Whereas this is now going to be a little bit better for us, I think, in the long run there. So let's do this, and the amplitude, we can maybe push it up a little higher here. Yeah, it's doing some kind of crazy stuff there. And maybe we just maybe, we offset this noise a little faster. Maybe we do 2.5, something like that. Yeah, that's doing some kind of interesting stuff. So this is great. I mean, this is working and doing kind of what it is we would hope for it to do, I guess. You know, we're getting some interesting results, and it's sort of pushing these values around and doing some stuff with it. So cool. We're working here, and things are kind of going the way we might want them to. And so we've got some interesting stuff happening here. It's weird because it almost looks a little bit like something from like a cloth simulation, almost, in a weird way. It's very strange. This is weird thing to see, like these Heightfields behaving like this. And Keith's asking, could you use any velocity volume for this, right? Yeah, you certainly could. I think the thing that you need to make sure is that I think you need it to be in the same like you want it to be an equivalent volume. I don't think you can do it with mismatching volumes, like in scale or in kind of structure, right? So I think you have to use matching volume types, and that's why I'm trying to do some of this stuff here, where I'm using kind of the sources as part of the process, because then that way you're not like trying to match new volumes, you know, two-dimensional volumes to these existing ones. Yeah, so you certainly could. What I would probably do with that is do something like a transfer. Yeah, I mean, that's an interesting question, actually. Yeah, let's try that actually, because I am kind of curious about this. I just want to see what happens if I multiply this by 0, because this should mean no velocity. I just want to make sure that this is actually going to do what I'm thinking it's going to do. Yep, no movement. Great. Yeah, that's a really interesting question, Enkeet, and I hadn't actually really thought of that. Let's play around with that a little bit. So, what do we want to do here? Let's just do a. Okay, so let's do a geo node here. Let's do a sim. Maybe we'll call a simple Pyro or something like that. I don't know. And let's just do a Pyro configure. God, I don't know. I guess a fireball? It's fine. Doesn't really need to be much of anything. Let's see here. Huh. It's actually too small in that case. Yeah, it's going to be really small. All right, let's just do this instead. Okay, what the heck? Let's do a sphere. And let's just use this. I'm just going to turn this grid on just so we can sort of see the scale of this. Because that's sort of our volume scale there. And let's ghost the other objects. Let's make this a bit bigger. And move it over this way. And then let's do a Pyro source here. Do a surface scatter. Probably something like that, I guess. Should work. Let's see if we do initialize. Smoke is fine. And cool. All right, so let's do rasterize, volume rasterize attributes. Let's see, attributes we want to do is density and temperature. That's cool. Kind of want to turn that voxel scale down. Maybe something like that. All right, and then if we do just a Pyro sulfur, should work, I think. And I'm just going to change the buoyancy so it goes in that direction. But let's just make sure that this is actually working. It's way too high resolution because I have the voxel size at 1. So let's do this. Copy parameter. Paste relative references. Cool. That's still probably too high resolution, so let's just do way less. Kind of doesn't matter too much. Split the difference maybe. Cool, cool. And then let's do just a little bit, maybe some turbulence here. pretty big, so let's see if that will do anything for us here. Cool. Okay, sure. Something like that. And then we'll just change the buoyancy to be 0. And what axis is that? Oops. Negative X. So we'll do negative that. Oh. Whoops. Wrong direction. There we go. All right, so we're going to do that. And maybe what we'll do as well is add a little bit of, actually, let's just make this a little bigger. I think that could be good. And then I'm also going to multiply the buoyancy scale. Maybe we'll just get a little bit more velocity out of it, something like that. I don't know. Sure. I'm going to do this. Doesn't need to be quite as high resolution. So let's just do that, see what we can get here. Cool, cool. You could obviously do this with a the 2D flip representation as well. You could do something like that. But let's just play with this. That's good. Let's do a null here. And what are we getting out of this? We should be getting the velocity. Yep, velocity XYZ. And let's just do a is it a Pyro bake volume? No, Pyro post process, and that's just going to turn these into VDBs. We can maybe resample the volume. And we'll combine them as well. And then we'll just blast away the other ones here. And we'll just keep vel. Say delete non-selected, and this will just be out vel. Cool. All right, so let's go back over to here to this Heightfield advection, and we should be able to let's see, we're going to do a object merge. Say get Pyro vel out vel. There we go. We should be getting that data in here. Yep. And if we play this back, I don't think we'll see anything, but we do have our velocity data here, so that's good. I'm gonna just take this because this already has like some of the vel stuff set up in it. I'm just gonna kind of gut it out so that we're only using some of this stuff. So I'm just going to take this stuff out and do a bind. Oops. A bind here. And just call this vel. And this should just go through like that. And we'll multiply this by constant. Maybe we'll give it a little extra speed just to see if this is going to do anything. And then I think I'm going to use this just to test and make sure it's working. So, that's weird. Oh, right. I have messed up. I messed up one thing. I need to make sure that this velocity is not, it needs that set vector because it's pushing it up and down. I'm like, why is this not working? There's a reason for this. All right, we just need to set that component 2. There we go. That should do it. There we go. Okay, so we're getting the actual advection here, which is interesting. So yeah, let's give this a try and see. We're gonna wire this in here and see what we can get. Yeah, it is working. That's pretty interesting. It's weird that it's kind of like eating away at the front side of it. I think that's because there's no like velocity volumes there. Like the volume is kind of starting or whatever, but that's kind of interesting. The other thing that you might want to do with something like this is, yeah, it's kind of weird. That's a wacky effect. That's kind of cool. So you could certainly use something like this. The other thing I'm kind of wondering if it would work better, just as I'm thinking about this, is if we took this here from our VDB analysis, we got our Pyro velocity, and instead of doing this, we'll say copy vel, and let's see if we can do this. So instead of this, what we would do is we would do a volume sample vector. I think this will be better. So sample position is going to be the position of those vectors that we're working over. We're going to go from input 2, second input. We can do primitive name. Yeah, it could also be that, Zach. That's a good point too. Yeah, Zach's saying that it could be happening because it's a low resolution, it's big voxels. Yeah, it could be. That certainly could be it. So this should be sampling the vel that's coming in here, which is that. Yeah, good. And then let's do this, and we'll just port that in instead. So this should now be keeping that same volume scale, whereas this one is, let's see, can we see the smooth wire, the wire shaded version of this? No, but this one is like square voxels. This one is just going to be a flat grid, so that might work a little better. Let's see if it works any better here. No, not really. Yeah, I think it might just be the front of this is like causing some weirdness there. But what this isn't going to do is it isn't going to change the size of it here. So that's just kind of reducing a little bit of what was happening there. So it's not like pushing the volume backwards as well, because we've basically fitted in our Pyro velocity into the scale of that. So let's just do this here. So this is copy simvel. And I'm going to do this. I'm just going to add a switch in here. Let's see. How do we want to do this? Let's pull this down so it's a little better, easier to see. And this over here. And I'm going to make a switch just so we can change this. You know, if you're looking to play around with this later, we can do that, and you can kind of switch back and forth. And here's the advect. Cool. All right, so now we can switch between those two, and here's a way to visualize that if you want to. So this is I'm just going to make some notes here a little bit, just clean this up a little. So this will be test advect. this is. Like so. Cool. All right, just so you know what the heck I'm doing here. Hopefully not too crazy. Yeah, that should be good. All right, so there we go. So now we've got this sort of thing that will do a few different options here. We could do it with the sim velocity, or we could do it with our why is that not working? Sorry, I think I set this to 0. That's why I was testing it. And actually, if I remember, there was different settings in here. I feel like I might have changed that. Nope, I didn't. I just thought maybe, because there's these different advections and things like that. So let's just go back here and see how that's going to look, if that's going to look any different. Well, it's definitely faster. Let's see. What about 5? Cool. Okay. So we can obviously play around with that. You can probably get more accurate, more effective results, you know, based on how many substeps you give this. It's probably going to give it a little bit more accuracy and things like that. So it's kind of just up to you to kind of play around with those things. And maybe this is better at like 1.5, so it's not maybe so fast. You know, that might be a bit more interesting maybe. Okay, so that's one part of it. Another part was, what if we wanted to add in, some like continual animation, so it's not just pushing around the initial, but we're adding some stuff in over time. Let's take a look at that and see maybe how we would do that. So the way that I did that was by, let's see here. So what we could do is, let me think. Because I did this a little differently, and I think it's actually a lot better here. Because what I was doing in my version before was I was converting it back and forth from a height field back into a VDB, and you know, back and forth every loop. And I don't think that that's like every time it's updating the solver, and I don't think that's particularly very efficient. So I think a better way of doing this would be to use height fields, right, to get some of these things. So like, for example, we have like a pattern here of some type, and maybe we do that, and we do, you know, something like that, right? And okay, so we have this pattern, right? And I think what we could do is take this and do the same thing here. Take this, copy this over here, and this will convert it into a VDB, right? So now we have that same information as a VDB. And what we could do then is put this into another auxiliary input here, and then come inside. And so this is input 1, this is input 2. Now we have input 3 that we're using. And what we could do there is, you know, add that into the previous frame, right? So based on, you know, whatever you might be doing, because really at the end of the day, like I was saying, these are just values that are stored in these voxels. So what we can do is we can add them together and then have that affect this in some, you know, in some way. So Yeah, so let's just kind of look at some interesting ways of maybe manipulating this. So let's just do another volume VOP here. And so this is going to be working on the previous frame coming in, or the first frame. And then this will be our input 2 on it. So if we go inside of this here, oh, actually, yeah, what we should do is do the HF VOP, height field VOP, because then we've got the height already set up. We don't have to deal with that. So now we've got this height here. And so what I'm going to do is do a volume sample again here. We're going to sample from that second input, and or we could just do this here as well. They're both basically the same. Let's do primitive name, and we'll make sure we're grabbing the height. And then we'll sample from this position of the current voxel that we're operating on. And we could add this together into the height. So we could just do an add here and do this, right? However, I think you might see the problem here is that we're going to do this add on every step. And so it's going to just kind of make these things go wacky and way up like that. So that's kind of weird. You don't really want that. So instead, what you might want to do is something like a maximum here. So that could be something we want to do instead. So we'll take the maximum of these two values, and that will be our setup. So let's take a look at this here. And those are actually not very tall, so that's part of the problem here too. So let's do that. Let's make these a little taller so they've got some height to them. Because I was like, wait, why am I not seeing that? And that's just because this versus that, there's a little bit of a height difference there. So we'll do 20. Maybe we'll do just let's just do maybe a little radius blur here so it's not like sharp. Just something like that. And there we go. We've got those working. And then what we can do is we can kind of have it's almost like an emitter then at a point, right? Like it's kind of like emitting into this, you know, from those points. And what we could do as well is we could, we could animate this a few different ways, right? We could take, we could animate it here at this height field level. This probably is the best spot to do that, I think, because it's a little harder to come inside of here and animate something. I think this is nice to just kind of have this as something a little simpler. You don't have to do animation inside of your solver. So I think this would be the best place to do it. So maybe what we do is just come over here and do a little wave effect on this. And let's see, we have our, let me just see how this is going to look. So if we're looking at this here, yep, it's just going up and down. And so let's maybe up the amplitude here to 20, and then we can do a period, maybe a little longer like this. Something like that. And then I think there was a might have actually been this square wave here. It was actually kind of interesting. We can do this, and then we can do bias. Then we can do what did I do with that? I'm trying to remember. Oh, yeah, that's what it was. I did a wave and then I did a filter. That's right. I forgot. Let's see here. Can we, let's bias this so it's just kind of like that. Actually, like this would be better. And then, just for a little chops fun, we'll jump inside of here. We can add a filter after this. What this is going to do is kind of smooth out that waveform for us, so we can kind of play around with that a little bit. And I think it's honestly probably fine like that. Play with that a little bit. Sure, something like that maybe. And then if we look at this here with our scene view, like that, getting a little weird animation there. It's kind of interesting. And that's what I was doing before. And I think what we might want to do as well is just offset this so that it starts. And let's just do this one here. There. So let's just offset it so it starts the phase here. Let's just do it so it starts down. Should be a little better. Like that. And then let's see here. Cool. Cool. All right. So now let's do this and we'll kind of let this play around and do some interesting stuff here. And this is, again, sort of what I was working with before. Now, the other thing that you might want to do inside of there is have a small bit of, kind of fall off with these, right? Because it's kind of staying at these certain levels, right? They're not actually, it's like kind of staying up high and it's not sort of decaying, right? So I think what we might want to do there is add a little bit of like decay into this equation here. So I think what we'll do is down here, we'll do another HF VOP. Drop this in here. And in this case, just trying to think. Yeah, so what we're going to do is make sure it stays at a, yeah, so I think what we can do is we can do the height. No, actually we want this to be a maximum again. So we can do the height. Do subtract. Let's do like this, and then I'll just promote this one so we can keep that up a level higher. We'll say subtract from height. We'll say sub height, like that. Cool, cool. All right, and so this should now subtract a little bit from each during each substep. So if we did something like 0.1 and ran this, we should see, let's see, reset that. Sorry. I think that's new. All right, let's just go crazy with this and just see if that's working. Yeah. Okay, so that is working. What I want to do though is make sure, because we're getting some weird situations happening there, I want to make sure that this is stays at a maximum of 0 and doesn't go too crazy. So let's do this. Let's do 0.2. I don't know why 0.1 wasn't working. Let's try that again. And then we'll do a maximum. We'll do a maximum between this and a constant of 0. So if this goes negative, it'll keep it. If this would turn it negative, it's going to keep it at 0 at the lowest value. So it's going to take the maximum between those two. So it means it should, I think that means it should never go below 0. Let's just double check. Yep. And so this should have this same kind of fall off nature where it's going to go down a little bit each frame and sort of continually go down. And so if I do this, just maybe we'll do it like 0.2. Yeah. So now that's doing sort of what we're expecting it to, where it's going to be slowly kind of reducing itself down as it kind of advects through this space. And so, so yeah, we've got this kind of interesting, weird kind of mush blend thing going on here. So yeah, I think it's kind of an interesting little effect going on here. Maybe the velocity is a little too high, speed wise. So we can always come in here and, sorry, not there, here, and just adjust this a little bit. Maybe it's 1.25 instead. And yeah, so we're getting some interesting velocity shifts and moves. And I mean, you can obviously take this same idea and kind of do any number of different sort of effects or, solves with it, I guess. You could certainly drive this velocity in a bunch of different ways, using different types of noise, different types of, whatever. So, I mean, here again, we have our noise velocity, and we actually had this before with the curl noise. We could try that again instead and see sort of how different this is going to look. Oh, you know what? I don't have that scaled high enough. Let's just do this at like 400 maybe. Interesting. Well, let's up this one here. 2.5, maybe do that. See where that gets us. Yeah, so obviously this is going to create different shapes and patterns and things like that in it. You might want to even, I don't know, maybe even go crazier with this. Yeah, kind of interesting. Getting some interesting results there as well. So let's see. Let's visualize this noise again here. Yeah, so you can obviously get all sorts of different effects and looks from this. This is certainly not like this is the only way of going about doing this. You could also, I think you could imagine a bunch of different ways that you could manipulate this same concept of using a solver to kind of animate and mess with these different, height fields and stuff like that. I mean, and you don't have to do this exact thing I was doing here with the adding the height values together. I mean, you can do all sorts of different things. The way I did it previously in this other example, just to kind of show you this really quick as well, was, I had this height field here, which I think was actually rotating. Yep. It was rotating the pattern is what I was doing. I wasn't transforming this with rotation. I was rotating this. So it just took this as the first frame. But what I'm doing in here then was just layering those two together and clamping the minimum there. So that could be, you know, a way to go about doing that as well. So if we look at this here, we're using Heightfield inside of the solver and then converting it, doing some blur here as well. Actually, that's kind of interesting. Maybe we should look at that in the VDB. Can I do a volume? Oops, sorry. Is there a blur for this? Let's see. Volume blur. Will this work? Maybe. Let's do something big, like 10. I have a feeling that's not going to work. Is there VDB smooth? I bet you that's what I want. Yep, I bet you that'll work. And then we'll do this with maybe Gaussian. Let's see. Well, yeah, that definitely blurred it. Okay. Let's see here. Nope. No, it's actually not even blurring it. It's just destroying it, it looks like. Yeah, that's not doing it. Oh, right. Do I need to do this just on height? Let's do mean just because, oops. Let's do mean because that's a little. Yes, 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 yes. Okay, so it is sort of working. World space units. Let's do it by like 5, maybe? Sorry, Ankit. I just saw your message about changing it after the solver. Interesting. Not sure why it's doing that. You could change it within the solver. So what I was doing here before is converting it. So it's coming in as Heightfield, getting converted, going through everything, getting converted back again, and then doing some Heightfield stuff down here. And so it works just fine. Just need to reset that. I actually think that might be interesting to play around with. It is quite a bit slower though, because it's doing all that converting back and forth. Is there a... Oh, no, it's on a VDB here. So this is a VDB, and the VDB smooth should be working on that. I just don't know why. It's not, like, it's just like destroying it. I'm a little curious about that. We'll do it on height again. Let's just see. What if I just go crazy with that? Is that going to do it? I just don't understand why neither of these directions seem to be working. Like 10 isn't working and crazy small isn't, like, that's even worse. Like, that's weird. Must not be able to do what I was kind of hoping for it to do there. That's probably why. I mean, let's just do this. Let's just do convert VDB back to a volume. I'm just going to do this just to see what it does. This should work. What just happened here? What did I just do? Oh, right. It's just not happy that I did that. And then convert it back to a VDB. And this, we don't want to blur it that much, just a little. Something like that. Maybe. Yeah, you could probably do something like that. Maybe do expand as well. What would this do? Yeah, that would just expand it out like that. Maybe do that and then do another one that does blur. I don't know. That could be kind of interesting. Let's see what that looks like. Nope. Oh, that's interesting. I was just thinking expand might do something kind of fun. Maybe it's just too much. Let's just set this back to 1. Yeah, it's kind of interesting. I'm kind of curious about this. It's kind of a weird one. Playing around with the expansion and blur a little here. You just created displacement? What is that? What do you mean I just created displacement? I don't know what that means. Why is this? I wonder, just kind of thinking about some things here. Yeah, exactly. So because we're doing this within a solver, everything's being cumulative. This is looping over this process every single frame. So yeah, for sure. Oh, you know what? This should probably be actually down here would be better for it. I think. Let's try that. Oops. Well, maybe, sorry, maybe what we do is we just do that a little bit more, just give it a little more subtraction from the height. Oh yeah, that's pretty wacky. That's kind of cool. So maybe we'll do like 1, just really push it around. Oop. Yeah, I mean, there's tons of different things you can do with this, right? Like, there's so many different options. So, yeah, I think it's pretty interesting, the kind of list of different things. Let's do this. I'm going to set this as a switch as well. So I don't think that's maybe by far the most interesting way of doing this, but we'll do that. And now it's just reducing too much, but that's okay. We can do that like so. Yeah, it's it's a pretty interesting process. I think it's definitely pretty unique. You know, and like I said, there's been some really cool stuff. Like Panoply's done some really interesting stuff with some of these kind of heightfields, you know, systems and things like that. So lots of sort of interesting ways that you could go about using this. And so I'm going to set this back to kind of how I had it before. I actually think that, this turbulent noise was maybe even a little more interesting. And yeah. Yeah, like reaction diffusion. Yeah, it kind of is, I think, and it's sort of in a way. You know, we're doing some weird advection stuff, but yeah, I think it sort of is. But yeah, and I think obviously another thing you could do too is instead of using just this really basic pattern that's just going up and down, you could have some like, you could actually create some geometry and have that projected into this Heightfield pattern here and use that to sort of affect this as well, right? You could have this pattern that's going, but you could also do like an HF project right there. And then you could do something like a sphere. Oops, sorry. Like so. And then, you know, you could do something weird like that. And we could animate this across or something like that, right? You could go like this. Across like so. And then you could actually have some stuff that would be like driven by this effect. You should see it coming across here soon. There you go. Get this weird kind of like sphere thing that's like almost emitting into it. You can see there it's kind of right in the middle. In fact, we should probably give that a little bit more because yeah, there it's actually not quite enough. Let's do this. Let's give it a little bit more like that, maybe. Sure. So now we should see that actually going across a little bit more when this sphere kind of comes out into the. And you'll see it's almost like it's like emitting into it, right? Because it's keeping that and sort of going to push that around in the simulation, right? So you can see you could almost draw, or not draw, but like you could sort of have your own effector, you know, things that are affecting this, right? So if we, for example, just turned this off, right? We should be able to see that a little differently now. So this is going to affect that. Oh, interesting. Surprise. It's like it like killed that off in a weird way, huh? Right. Yes. So that's sort of interesting. It's almost like it's seeing that has no value to it, or it's like going down to 0, and it's making it like unhappy. So maybe what we should do here is, instead of subtracting from height and the minimum is 0, we should have the minimum be something like that. Then it shouldn't do that anymore. Let's try that, because I think it was trying to prune those values, if I'm not mistaken there. Okay, so let's do this. Let's get rid of this. Let that move around. Yeah, there we go. So you just don't want it to go down to 0, because then it's going to try to prune those values out, right? So this is now kind of like emitting into there, right? So it's like this is now advecting off of that as like almost like a source for it. So it's kind of really, really weird looking, but it's basically like emitting that height into this advection and then using that to kind of move things around from there. So totally different way of kind of going about working with this, but you know, you could do something like that where you had an object that was advecting through it. You could have a bunch of scattered objects that would kind of do the same kind of idea. Kind of the sky's the limit. So, yeah, it's all there. It's all possible, right? So, I think that's where we'll start to kind of call this here. I think hopefully this all is making sense. We're really just pushing around these values using our velocity field, really, and we're pushing, instead of a mask value that's from a 0 to 1, we're pushing around height values that range in intensity. So this is all sorts of different ways that you could go about doing this same thing. And in fact, let me do this too, because I can rotate this. Where was that? Rotate here. So we'll just do this, and then we'll move this along, to the end. We'll just do like a 360. I don't know. No, we'll just do, we'll just do $F times 4. I don't know. That's probably good. Then that should give us some, instead of kind of going up and down in the same spot, they'll kind of do these weird random rotations and stuff. Make some really weird stuff. Actually, we could do this. Let's do this. Let's do times 3, just a little slower. Felt like it was just a little on the fast side. And it's going to actually hold on to where those, where those are moving through this field, right? So like as they're like rotating, it's going to go like, it's going to remember those frames and kind of keep them in there until it dies away, right? So some interesting stuff, all sorts of different weird things you could do with this for sure. And it's definitely a really abstract thing, but I think you could do some really, really unique stuff with it. And another thing you might even try doing is maybe advecting some colors through it or something like that, right? Because if you were looking to advect, that's actually really fast. How fast it's spinning. It's kind of silly. Maybe this is even 1.5 or something like that. But there's all sorts of different things that you could do with this, right? You could advect colors or other attributes through it and change, use masks to advect, kind of like we were doing before. Yeah, it's a really weird thing. It's just really strange looking because you're only actually editing this flat volume, right? So it's kind of this really strange situation where things are you're doing some really, really cool, like you can make some really interesting effects with it without having to worry about like 3D, like where all these pieces are moving in 3 dimensions, and still able to control them really. So, yeah, anyways, well, yeah, I think, like I said, that's where we'll sort of start wrapping this up for the day. As always, this file will be available online to download through the Discord server. There's a link to a Google Drive there that I upload everything to when I'm done with my streams. So, please feel free to grab that and kind of take a look at what it is we were doing here, and you can kind of pick it apart and try to get a sense, maybe a little bit more of what's going on in here. So, yeah, you're very welcome, Robin. Thank you for being part of the stream. Thank you everybody for being part of the stream as well. Yeah, hopefully we'll be getting back into a little bit more of a regular rhythm of these. The last couple of weeks was definitely hopefully a bit of an anomaly here, but I do have some travel coming up for FMX, like I said, so I will have a week off later in April. But also, friendly reminder, if you live in North America, there's a eclipse happening. So if you happen to be in the path of totality, go enjoy that, because it should be a pretty cool event. Won't happen super often here in the United States, or really anywhere. I think it's something along the lines of like every point on Earth, or most points on Earth, will have an eclipse like on average of every like 300 years or something like that. So a total solar eclipse. So it's definitely a unique kind of thing to get to enjoy if you're around. If not, enjoy the pictures that'll be coming out, because that's what I normally do. So it's my turn this time. So I'm looking forward to it. Kind of goes right through my city. So hopefully it won't be cloudy. But anyways, thank you all for joining. And as always, keep an eye out to, for socials and things like that for what topics we'll be touching on in the future. And always submit your suggestions to the Houdini Hangout Discord. If you haven't joined that before, you can go to Houdini Hangout. There's an invite on there, and that'll take you to the kind of to be a part of that community. It's been really great. A lot of people have been. I don't think I have that set up, La Pampadura. Sorry about that. I think that's a Twitch thing, but I don't. Again, I'm getting painfully too out of touch with some of these things, but maybe I should figure out how to do that. Anyways, maybe it works. I have no idea. I don't think it does, but you're already in. Good. But yeah, please join there. There's like more and more people are kind of using that as a place for help for different things. And that's great. That's exactly what it's there for. So if you're running into a problem and you'd like, some eyes on what you're running into or have questions or thoughts, it's a community for chatting. I can't say that I'll always be able to get to them right away, but a lot of times other people jump right in and help as well. So it's been really great to see that. So, so thank you everybody for joining this evening. And like I said, we'll be planning on some streams next week. So hope to see you then. Everybody have a great night, and I'll talk to you later. Bye.